Okay, here in section 15, we're going to do a fair amount of math. It's not complicated math, but it is indeed math, and our recommendation is, and we recommend this for all sections, but this one especially, you're going to have to stop and study this stuff. We're going to run through it. We're going to do the standard system and the metric system. It is likely you'll have to go back and review this material. Step 1 for calculating weight or measure using the standard system. Weigh all of the cartons or crates for a given shipment. Be sure to express the weight in kilos, recalling that 1 kilo equals 2.2046 pounds. Step 2. Convert the total number of kilos to metric tons, also recalling that 1 ton equals 1,000 kilos, and round up or down if necessary, bearing in mind that 10,000 kilos, for example, equals 10 tons. Step 3. We want to express our metric tons as cubic meters. Again, 1 ton equals 1 cubic meter. In the example we gave a moment ago, it was 10 tons, but we want to express that as cubic meters. But for now, the number is 10. Step 4. Now we're moving on to the measure component of the calculation. We just went through the weight part. Now let's move on to the measure part. Take the dimensions in inches of each carton to determine cubic inches and then add them all up together based on the number of cartons and the dims of each carton. Step 5. Divide the total cubic inches by 1,728 to determine the total number of cubic feet. 1728 is not a random number. It is the number of cubic inches in a cubic foot. We're getting close, but in step 6, we want to convert from the standard over to metric. So we're going to divide the total number of cubic feet by 35.315. Why that number? Because, as we see in our sub-bullet, there are 35.315 cubic feet in a cubic meter. Now we're working in cubic meters. Step 7, compare the actual weight in metric tons to the volume weight. Let us say that the example where we had 10 actual metric tons of cargo, but the volume calculation took us to 20 cubic meters, the charge is going to be on the 20 cubic meters, and that's what we see in step 8. The LCL rate applies to whichever is greater, the weight or measure. We have an example. We'll continue to illustrate the point. What do we have here for our sample calculation? Still on the standard system. We have a U.S. importer of car parts that needs to carry out a weight or measure calculation for an import shipment. Right out of the gate, we can say to ourselves, well, car parts are pretty dense. Might this be a dense shipment? Well, that's going to depend, as we'll see in our next example, on how goods are actually crated or packaged. In this case, second bullet point, what's our configuration? We have 7 skids, 7 pallets, with a total weight of 35,275 pounds. We have our dims of the pallets, 48 by 48 by 48, each carton with the same dimensions for ease of calculation purposes. The big question, which is greater, the actual or dimensional weight of the shipment? Let's find out. Let's run through our steps. The total weight of the shipment, 16,000 kilos. We took 35,275 pounds and divided by 2.2046. Step 2, we know this. 16,000 kilos is the equivalent of 16 metric tons. In a weight or measure calculation, noted in step 3, 16 metric tons equals 16 cubic meters. We know that. Let's keep that 16 number in our head for now. Step 4, moving on to the measure component of the calculation. The total cubic inches of the shipment is 774,144. That's just 48 by 48 by 48 times the 7 pallets. Moving over to the right-hand side, step 5. We want to get to cubic feet, we will recall. So we take our cubic inches, 774,144, divided by 1728. That gives us 448 cubic feet. We're not done yet. We have to get to cubic meters. That's step 6. The conversion from cubic feet equals 12.68 CBMs. We'll round up to 13. Where did that come from? 448 cubic feet divided by 35.315, which is the number of cubic feet in a cubic meter, to give us that 12.68. We'll round up to 13. In step 7, we will recall that the actual weight expressed in cubic meters is 16 CBMs, 16 metric tons. But the volume weight is only 13 cubic meters. So the cost is going to be based on the actual weight, the 16 metric tons expressed as a cubic meter. Rounding out step 8, if the LCL rate was $100 weight or measure, then the cost of the shipment would be $100 times 16, which equals $1,600. In this instance, the freight was more dense than it was voluminous. Let's move on to the metric system. Same idea, using metric, because oftentimes the DIMs that we get from our suppliers overseas are going to be in centimeters. We need to be able to do weight or measure calculations in both the standard and metric system. Step 1, weigh all of the cartons or crates for a given shipment in kilos. We know this. Step 2, convert kilos to metric tons. Round up or down as we saw previously. Step 3, the same. Express the metric tons as cubic meters, remembering that 1 ton equals a cubic meter. Step 4, this is where it starts to get a little different in the metric system. Take the DIMs in centimeters of each carton to determine cubic centimeters and add up all of the cubic centimeters of the cartons. Step 5, equally different from what we saw in the standard system. Convert the total cubic centimeters to cubic meters by dividing into 1 million. Where does 1 million come from? There are 1 million cubic centimeters in a cubic meter. That's the crux of the conversion, step 4 and step 5. In step 6, we compare the actual weight in metric tons to the volume weight expressed in cubic meters. Step 7, the LCL rate applies to whichever is greater, the weight or the measure. Simple stuff, right? Let's do another example. A consolidator in Asia receives an LCL shipment of spare parts for agricultural equipment and needs to determine the weight or measure calculation. Once again, we might think that spare parts, they must be heavy, it's agricultural equipment. Sure, it's likely that they are. But weight or measure is also influenced by how goods are packaged or crated. Let's look at our configuration. We have 10 crates with a total weight of 2,000 kilos, 200 kilos apiece. The DIMs of the crates are all the same, 150 centimeters by 125 by 100. Our big question, which is greater, the actual or dimensional weight of the shipment? Step 1, we already know that this shipment weighs 2,000 kilos. Step 2, we also know that 2 kilos is the equivalent of 2 metric tons, and that 2 metric tons can be expressed as 2 cubic meters. That's in step 3. Easy breezy. Step 4, here's the conversion. There are 18,750,000 cubic meters in this shipment. That's just taking our DIMs in centimeters and multiplying by the 10 crates. We can say in step 5 that there are 18.75 cubic meters of volume weight for this shipment. Round up to 19 CBMs. That's that 18,750,000 divided by a million number of cubic centimeters in a cubic meter. Step 6, the actual weight of this shipment is 2 tons, 2 CBMs, but the volume weight came out to 19 CBMs. In step 7, we see that if the weight or measure price for this shipment was $100, the forwarder would charge $1,900 for the LCL ocean transportation. Admittedly, this is an extreme example to illustrate the idea of voluminous cargo and that it's not always just ping pong balls. It certainly could be, and certain cargo has voluminous characteristics by definition. We wanted to provide an extreme example to illustrate the point. 2 metric tons of actual weight up against 19 CBMs, that is an extreme example, highly illustrative of what we're trying to convey. All right, that's it for LCL and weight or measure. When we come back, we're going to look at ocean import documentation for all kinds of ocean transportation, FCL, LCL, etc. We'll be using our Zoom feature quite a bit in these upcoming sections, so please come back quickly.